aluminum rods in and out of the solution. So that's kind of weird, and we want to find perhaps another way to measure that can also act as a noise reduction, so we don't get a lot of electrical noise. Here are our references for both Nathan and myself. Special thanks to the Research Corporation and Humboldt State University College of Natural Resources and Sciences for funding. Can I entertain any questions? Yes.
Well, it seems like this device would have lots of application, not just to this experiment, but so the idea is that it's the fluid level that would change. So it would be effectively dipping two plates in out. You're not. It's not the suspension of the plates.
Actually, we are. I'm going to
over there.
Draw you a cross picture of what it's going to look like. Do it by this impromptu bridge circuit. So this is going to be the lid, and we're going to have rods that are hanging from the lid, and we're going to get a top that sort of screws on to avoid any evaporation that doesn't need to be there. And our solution is going to be like this. So the rods will be suspended in it, but they'll all be equally suspended in it. This actually does, as you said, have a lot of applications, and there are industrial ones available, but they are absurdly expensive, especially for the sort of sensitivity that we need, and for a poor physics department, as you know, most physics departments are. So I was looking into it, and I can build this. I don't understand why I couldn't build this. And then we can also tailor make it for our specific needs. So this does actually have a lot of commercial applications. They use them a lot on forklifts to make sure that they're kind of topple over, shipping, all kinds of stuff. So, yeah. Did I answer your question? Any others? Yeah.
What is the recovery time of the sensor, and if could we affect its recovery time by somehow?
Yeah, we could. You mean like if there's an earthquake and?
Yeah, like so how long? I mean, how sensitive it's in the frequency domain?
How sensitive is it in the frequency?
Yeah, so if you have oscillations with 1 hertz or 0.1 hertz, it wouldn't register them. If you have oscillation 1,000 hertz, it would register them. So what is the sensitivity, time sensitivity of the device?
The time sensitivity, well, it happens. I mean, it's like if you had a glass of water. I mean, how long does it take the glass of water to sort of chill out after you set it down or whatever?
What is this time like?
It's fairly quick. I haven't actually measured it, so I don't have an actual time for you. But as far as earthquakes are concerned, we have the USGS to help us out with those, so we can definitely take those time considerations in. And it's always easy also to subtract out certain data, being generous on either side. But that's a good question. I haven't actually measured how long it takes for the system to return back to normal. Because there is going to be sodium bicarbonate in it, that thickens up the water a little bit, so the viscosity is higher, so it's not going to, it's going to slow down more. And there are actually some other things that we can use to put in the solution that won't affect the capacitance. That will also thicken the water and slow the evaporation time. So
we're interested in really slow modulations of the tilt. So, we're interested in what happens over hundreds of seconds for our experiment.
Yeah.
Is the highest frequency we're interested in.
So you could use a gel or something
almost.
Yeah, there's. I was messing around with the idea of putting an oil layer over it, and I did this experiment in my kitchen, and actually managed to suck a whole one dry. But I put 2 thermoses and put just a layer of oil on one, and the other one completely evaporated in about 2 months, and the one with the oil on it didn't evaporate at all. But then again, the oil could coat the aluminum, so that might not be a viable option. But it's things like that are definitely something to look into. So.
You mentioned a sensitivity of a microradian.
Of a microradian in this direction.
Right. Yeah.
So we've got
How do you estimate that?
that's the industry standards is